For over 1,000 years, people believed Earth was the center of everything. This idea came from ancient Greek thinkers like Aristotle and Ptolemy. Their ideas became ingrained in religious teachings. The universe was seen as a series of perfect spheres, with Earth at the heart. People looked up at the night sky and saw the stars and planets seemingly moving around us. It made sense to believe that we were the center of it all. Questioning this view was not encouraged. It was seen as challenging the established order both in science and religion. The universe was ordered and unchanging. Our place within it was fixed. This view of the cosmos was comforting in its simplicity. It placed humanity at the center of creation, but it was a view built on assumptions, not on evidence. It would take a revolutionary idea to shake the foundations of this ancient belief. The year 1543 marked the beginning of that revolution. In 1543, a Polish astronomer named Nicholas Copernicus published a book that would change our understanding of the universe forever. The book was titled Or. In it, Copernicus proposed a radical idea. The Earth was not the center of the universe. Instead, he said it revolved around the sun. This idea, called heliocentrism, was a direct challenge to the accepted view of the universe. It was also a dangerous idea. To suggest that Earth was not the center was to question the teachings of the Church and the very nature of our place in the cosmos. Copernicus's book was not immediately accepted. In fact, it was met with resistance and skepticism. But the seeds of doubt had been sown. The idea that the Earth might not be the center of everything was out in the open. Copernicus knew his ideas were radical. He was afraid of the reaction from the Church, so he delayed publishing his book for many years. In fact, it was published just before his death in 1543. He even dedicated the book to the Pope at the time, hoping to soften the blow of his revolutionary theory. Despite his caution, Copernicus's work sparked controversy. Some scholars embraced his ideas, seeing the elegance and simplicity of a sun-centered system. Others condemned it as heresy. The Church, which held great power at the time, largely rejected heliocentrism, seeing it as a threat to its authority. But the idea was out there, and it would inspire other astronomers to look at the universe with fresh eyes. The quest to understand our place in the cosmos had taken a dramatic turn. The stage was set for a new era of scientific discovery. Copernicus's work inspired other astronomers to make their own observations. One of these was Tycho Brahe, a Danish nobleman with a passion for the stars. Brahe built sophisticated observatories and meticulously tracked the movements of the planets for over 20 years. His data was incredibly precise, even without the aid of telescopes. Brahe's assistant, Johannes Kepler, inherited his trove of data. Kepler was a brilliant mathematician who used Brahe's observations to develop his laws of planetary motion. These laws showed that planets move in ellipses, not perfect circles, around the sun. This was a major breakthrough, further refining Copernicus's heliocentric model. Kepler's work provided a mathematical framework for understanding the movements of the planets. His laws demonstrated that the universe was not random or chaotic, but governed by predictable patterns. This was a crucial step in the development of modern astronomy. So, in Italy, Galileo Galilei was using the newly invented telescope to make some truly astonishing discoveries. He observed mountains on the moons orbiting Jupiter and even phases of Venus. These observations, they offered powerful support for Copernicus's heliocentric model. They showed that celestial bodies weren't perfect, unchanging spheres, but had their own unique features. Galileo's discoveries, which he published in his book, made him quite famous. But they also brought him into direct conflict with the Church. His support for the heliocentric model was seen as heresy. He was put on trial by the Inquisition and ultimately forced to recant his views. Still, despite the Church's opposition, Galileo's work had a profound impact. His observations and writings helped popularize the Copernican revolution. He really showed the power of observation and experimentation in challenging long-held beliefs. Galileo's legacy would go on to inspire future generations of scientists to question, to observe, and to explore the universe around them. The work of Copernicus, Brahe, Kepler, and Galileo marked a turning point in how we understand the world. It wasn't just about making new discoveries. It was about embracing a whole new way of thinking. This new approach was grounded in observation, experimentation, and mathematical reasoning. And really, it was the birth of what we now call the scientific method. Thinkers like Francis Bacon and René Descartes played a huge role in shaping this new mindset. Bacon argued for the importance of observation and experimentation. Meanwhile, Descartes emphasized the power of reason and logic. Together, they laid the foundation for the scientific revolution that would go on to transform the world. The shift, from relying on ancient authorities and religious dogma to embracing observation and experimentation, was pretty profound. It marked a move away from simply accepting what we're told to actively questioning and testing our understanding of the universe. The Catholic Church, well, it played a pretty complex role in this whole scientific revolution. On one hand, the Church had preserved ancient knowledge and even supported some scientific inquiry. But on the other hand, it resisted ideas that challenged its authority, as Galileo's experience clearly showed. His trial really highlighted the growing tension between the old and new ways of seeing the world. Galileo's condemnation had a chilling effect on some scientific inquiry. Still, it also underscored the importance of intellectual freedom and the right to challenge established ideas. The seeds of doubt sown by Copernicus had grown into a full-fledged revolution, one that the Church could no longer ignore. Despite the resistance, the scientific revolution was gaining real momentum. The power of observation, experimentation, and reason was just too compelling to ignore. The world was standing at the edge of a new era of discovery and innovation. The year 1543. It wasn't just about a book or a theory. It was really the start of a revolution. And this revolution wasn't fought with swords or armies. It was fought with telescopes, equations, and honestly, a relentless curiosity about the universe. It's a revolution that still continues to this day. The scientific revolution ushered in a whole new era of understanding. It led to breakthroughs in medicine, in technology, and in how we see the universe. It gave rise to the Enlightenment, the Industrial Revolution, and even the Information Age. It put humans on the moon and sent probes all the way to the edge of the solar system. The story of 1543 reminds us that our understanding of the universe is always evolving. It teaches us to question, to explore, and to never stop seeking knowledge. And maybe most importantly, it reminds us that the greatest discoveries often come from daring to challenge the status quo, and from dreaming of an entirely new view of the cosmos.